Okay, so this next one, no pressure here. This is, I'm about to introduce my boss, so I got to get this one right here. My job, I'm the Chief Technology Officer for SANS Internet Storm Center, right? And I had the pleasure of picking up that position where we maintain over 3,000 honeypots all over the world. And I was hired by the guy who created the Internet Storm Center when it was DShield, right? DShield was the original one. Or was there a name before DShield? No, it was originally dshield.org. And when was that? That was back in 2001, DShield was created, where we have Internet Storm Center handlers and all that stuff. But so it's my pleasure to introduce Dr. Ulrich, Dr. Johannes Ulrich. His official title is the Dean of Research at the SANS Technology Institute. He's a SANS faculty fellow. The founder of the Internet Storm Center, dshield.org, where you get free analysis. So we have our honeypots. You can download all of the data we collect from all of our honeypots. There is free threat intelligence. We also have Internet Storm Center handlers who are analyzing that data and posting journal entries each day with things that are relevant. And of course, then there's the Internet Storm Center threat, I forget what we call it, the threat icon, which is either green, blue, lets you know what's going on. I think the thing has only turned yellow or orange like 15 times since 2001 when it's created. So if that's red, it's going to be a bad day, right? Because we've had some bad days with malware. It's only gone to yellow or orange. I think it was orange for like a half a second or something like that. Yeah. Dr. Ulrich is also the author of several SANS courses. He's an instructor and an author for SEC 546, which is IPv6 Essentials, co-author of 522, Defending Web Apps and Security Essentials, and he teaches 503, Network Monitoring and Threat Detection in depth. So with that, join me in welcoming Dr. Johannes Ulrich.
I think I need this one as well. Yeah.
Okay.
Yeah, good.
All right.
Okay. We have it all up there. Good. Yeah, first of all, thanks for having me here in Augusta. Here, I'm living actually in Jacksonville, Florida, so it was a really reasonably easy drive up here. And also thanks for the introduction here by Mark. I think I'll keep you around for a little while longer. Anyway, so what I want to talk today is developers and some of the threats that developers are facing, which is something that I think is a little bit underestimated somewhat. Over the last few months, actually, I think it became sort of more a public thing, what really happens here with developers. Don't really have to, let's look here, yeah. Don't really have to introduce myself because Mark already did a great job for me. I originally grew up in Germany, but what surprised me a little bit is why am I invited here for a keynote speech? I guess it's Mark's fault somewhat. Yeah. But I've been in this industry really too long to give a speech like this. They should have one of the young kids here do it. Yeah? You still look like you believe you can make a difference and such. When you're doing this for 20, 25 years, you get two kinds of speakers. You get the jaded speaker who pretends that you can make a difference, and you can get the jaded speaker who, well, basically just jaded. I'll leave it up to you what I'll end up with doing here during this presentation. Hope a little bit still get a little bit that make a difference part across. It's a tough business. It's a tough business to really, in particular from the education front. So I'm teaching, as Mark said here, for our graduate school in particular, a lot for SANS.edu. And it's kind of hard to see people making the same mistakes over and over. And in part, that also is a little bit what that talk is about, that things like trust in tools, basic things. Then we had just earlier someone from the AI part here introduce themselves and introduce the facility. Anybody remembers buffer overflows? Anybody knows what the big problem was with buffer overflows? failure to balance check is, no, that's not a problem. It's mixing control plane and data plane. It's mixing data and code. What's a prompt injection? It's mixing data and code. It's mixing control plane and data plane. But well, we'll learn it again. Eventually they'll fix buffer overflows and prompt injections. Anyway, so that's enough in the introduction. So developers. You probably all remember, that famous, Steve Ballmer. I'm a bad Steve Ballmer impersonator, so I won't really do the developers thing that he did at that famous conference when they, Windows XP or whatever they introduced there, when they sort of had that big introduction. And but the reason what I like about this is it really shows the importance of developers. Developers are those people that hide in their cubicles, that don't really, talk to other people. So they sometimes are a little bit forgotten and lost when it comes to security too, but in business in general, where they're kind of ignored. But at the same time, developers are your supply chain. Everybody talks about supply chain risks. But what is the supply chain when it comes to software? It is your developer. Your developer puts the software together in the end. And that's here the big problem. And we have day after day pretty much the same problems in the news these days. I sort of picked a couple of recent headlines here. The one just from this week with like that big NuGet. Not sure if you're familiar with this. It's like the .NET ecosystem. So like your pip and NPM for .NET. That's sort of where that comes in. And of course, that's what I referred to earlier when I said that finally it sort of gets a little bit in the public, more public conscious kind of this problem. And that was like that big Shai Hulud worm here that infected NPM repositories at the large. Anybody knows what module actually was infected there? It was actually a kind of a neat module. They call it, it's one where if you display code as part of your software, it nicely marks up the code, sort of, give it nice colors and such. But in particular, when you talk about NPM, this module itself, I think when I count it, depends on like 256 other modules. Being a little bit an old-fashioned developer who isn't really used to quite some of these ecosystems, did you know that one of those 200-something modules is just removing spaces from both sides of the strings that you're including? So it's these huge, complex ecosystems. Anybody ever played with Electron? Electron, that framework, you've done that? It's actually a neat idea, Electron. Slack, for example, is a famous application written in Electron, like if you're using the native application, there are a couple other big ones, but it allows you to use JavaScript and HTML to write native applications. There are a couple of frameworks like that. I played with it. I think the Hello World application when I wrote it, something like 370 dependencies. Not sure if you're coding that, you may know the exact number, but nobody's ever going to tell me that they verified all of those when they included this. And this is really one of the big problems. So developers are your supply chain. And as part of your supply chain, they have access to everything. Those people you never talk to, or, well, some of you may actually hear they're probably sitting in the back, the developers. Anyway, so they have access to your source code, which often is your intellectual property. They have access to credentials in order to connect to customer data. Yes, we all, as developers, and I'm kind of a developer myself, I admit. We're supposed to have special developer databases with data, for developers to use. But ultimately, you have to make sure that that data is actually correct. You have to have access to real data to create that, test data, if you even use that. And of course, quite often, we don't use test data. We do use real data. And with that, stuff like that gets leaked. So all that confidential, your development pipeline, which is another important sort of business secret. What's the next product we are going to develop? How are we going to finally shoehorn AI into our product to make it a little bit more sexy or such? So all of that, developers know about it. So I want to start with 3 threats here that I sort of see as important. And then I have sort of a 4th bonus threat at the end. And I'm going to cover them sort of in inverse order. I'm starting with what I consider the less severe ones, a little bit, or the easier ones first, and sort of work my way down the list here until we sort of get to really, I think, the big one here, which is of dependencies. Anyway, what kind of really made me aware of what's going on here was this LastPass compromise from a couple years ago. Not sure if you still remember. The LastPass, nice software. They make this password manager. They were compromised. And as part of the compromise, customers' encrypted password data was stolen. And actually then later it turned out, because of, well, hashing, encryption, stuff like this, obviously a little bit tricky to get right, because they didn't quite get it right the way they probably should have gotten it. Some of that data was actually decrypted and then used by the attacker who stole it. So how did that happen? We have our developer here. And in my talks, I always use dogs for the good guys and cats for the bad guys, because anybody who ever had a cat knows cats are bad. But anyway, so we have our developer and we have our customer secrets. How did the attacker get from that developer in the lower right-hand corner here all the way up to the customer secrets? Well, developers need workstations to work with, and developers want to have fun. Anybody here, when they're coding, likes to listen to music? Or such? Yeah, it's very common. So this developer had Plex installed on their coding machine. Okay, watching videos while coding, I'm not sure, but either way, that's sort of what they had here. Okay, so what happened next? Turned out Plex here had a vulnerability, a relatively straightforward remote code execution vulnerability, where you could connect to Plex and trick it into executing code. I think you just had to upload a file and get access. So it was a relatively easy to exploit vulnerability. An attacker found this vulnerability, and this was the vulnerability. It was an older vulnerability. It was a couple years old at the time it was exploited. But then again, software like Plex or so, that's not part of your corporate patching framework or vulnerability management system and such. So it just got lost. Who knows? Maybe he wasn't even using it actively. And that also happens. I think I have a system at home where I have Plex installed just because I was playing with it. And yeah, I got bored with it, had real work to do. And it's now sitting there on the system. I hope I keep it updated. I should check when I get home. But anyway, so they exploited this vulnerability. And with that, they installed a keystroke logger, so standard, kind of a malware that you commonly find in exploits like this. And with that keystroke logger, they were now gaining access to anything that developer typed, including credentials that gave them access to their customer secrets. So there was a specific encryption key here and some credentials to access cloud storage and such that this developer had access to. Once the developer used it, the attacker was now able to access that cloud storage directly, download all the customers' encrypted vaults, and rest is history, as they say. Now customers' most secret passwords are out there. Yes, in an encrypted form, but you can't hash them because you actually have to use them in the password manager. The password manager has to eventually know what these credentials are for a password vault. And that was just a matter now of basically brute forcing whatever password the user used to secure that vault. So that was really then the only thing that stood between the attacker and all of these secrets. Anyway, Yeah, so one person essentially blew up the entire company. Now, LastPass still exists. They survived this particular incident. But the worst possible compromise for a company like this is losing customer secrets. And it's also a big part of the business. I remember the old day, I use 1Password a lot, not much LastPass, but when they came first out, you could synchronize your vaults directly, like system to system. They just had to be connected to the right wireless system. I actually like that. But the problem was you paid for the software only once this way. And now to make it a subscription, they all make you use some kind of cloud service to synchronize your passwords. So that means these passwords are now, or these password vaults are now accessible to an attack like this. Could it be used? Could definitely be me. Yeah. So this is definitely one of those things that I think anybody here probably has some software on their system that they're using to develop code that may not be strictly necessary to actually write code, but is nice to have. And whether that's various messengers that you're using, some of them may be needed for sort of corporate communication, but some of them you just may have like some Discord or whatever to link up with other developers, ask questions and things like this. That you have here on your systems. And then what you have noticed, something like this happening. And I'll talk later a little bit about some of the challenges when it comes to protecting developers. So anyway, so all of these unrelated software that you have on your system, email clients, web browsers, which are a huge attack surface. Just last week, OpenAI came out with their browser. And as a developer, I haven't gotten around to it yet, but as a developer, I expect you to experiment with that. To see, hey, what are they doing there? Is this anything that we can use? And of course, the day after they released it, people listed all the prompt injections and so that you have in that browser by just visiting the right website, an attacker can take it over. And yeah, as a developer, you often deal with insecure software. That's part of what you're doing. Also, out-of-date software. I don't do it that much these days anymore, but I remember in some prior project I was working on where I always had to have some old version of Java sitting on my system because I had to test if my software works with those old, outdated versions. Or old browsers and things like this that you need for testing. And yeah, that's again sort of a risk that you're accepting here as you're developing software. So how do we fix it? Patching, of course, the obvious fix here. Is everybody's software patched all the time? Particular software that you may not necessarily have sort of in some kind of corporate inventory or such. So it's hard. It's hard to get that right. It's particularly hard if you have these unique requirements for developers, like the need to sometimes have out-of-date, buggy, vulnerable, known vulnerable software on your system, because you need them for these tests. And that makes it particularly difficult. So sometimes you can have sort of these virtual machines with like the outdated stuff. Now, I've done that plenty of times. They sort of keep an old. Anybody ever had that problem with like the old BIOS control systems like IPMI and old Dell DRAC stuff and such that required a very specific Java version or such to run? And in those cases, like, yeah, virtual machine will do. So that's one way of doing it. Endpoint protection software, we'll talk later a little bit about the difficulties with endpoint protection software or network protection software and developers and some of the specific challenges you have there. One thing that would have helped in the LastPass case is that idea of a privileged access workstation. Anybody ever used something like this or has experienced? I see a hand going up back there. Not a lot of hands going up here, but the idea is, well, the developer's workstation should never touch live credentials to connect to your cloud storage. And the idea of a privileged access workstation is you have one workstation that's really locked down that you just use for these specific use cases. I find it works. It sometimes works better in theory than in practice. It takes work to get it actually to work correctly and set up correctly. And it often gets in the way too, like, if you have to move some larger code updates live and such, where depending on, again, how you're set up. The other problem that you deal with here is these things weren't created last year. Like my code base, Mark mentioned earlier, I started writing on that site in 2000. There's still some code from back then. And yes, I get embarrassed when I see it these days, but realistically, you always have this legacy that you have to carry around with you, and that sometimes gets in the way of these a little bit more modern solutions. And nobody has the time to rewrite all of their code all the time. So, next thread, developer tools. Developers need tools. Yeah, I still do a lot of coding in Emacs. That's my editor of choice. Some people prepare VI. I never really got used to that. But most of the time, if you really want to develop well, if you want to develop fast, if you want to take advantage of a lot of the modern stuff that you have, like even vulnerability scanners and things like this, you probably use some kind of IDE. You use Visual Studio Code, you use JetBrains, or all these different nice IDEs that are out there that help you write better code. These IDEs are great, but there's always something else you could add to it. Dark themes. Developers love dark themes. The darker the better. Sort of dark gray font on a black background, and such. Sometimes the tools don't come with those themes and such pre-installed, or extensions that you have. So all of these tools have these extensive extension stores that you can use to download these extensions, themes, and the like. What a lot of developers don't realize, as soon as you load that extension or a theme, you give that code complete access to everything you're doing. And there's usually no real good way to sort of separate this. Even those different colors need code to run. And this has become a huge issue. VS Code and OpenVSX. OpenVSX is an extension store for, well, VS Code versions that aren't VS Code. Visual Studio Code, there are a couple of other IDEs that are essentially sort of wrappers around Visual Studio Code, and they have their own extension store. And so that's sort of where they come in. But here's an example. So you're a developer. You heard about this AI and vibe coding thing, and you want to start using Copilot as part of your day-to-day development. So you need an extension to run Copilot. On the left-hand side here, you do see the extensions that you sort of see at the top of the list. And you see there's some obvious good ones, like there's sort of an official GitHub Copilot extension here. And that's probably what you want to do. But then there are others that sound interesting too. And I'm not saying any of these are, I picked them like earlier this week, so I don't think any of them here are malicious. But how do you tell? How do you tell? Yeah, maybe you speak Chinese, so cat GPT. The cat should give it away that this is bad. But other than that, black box AI, I have no idea. It seems to be popular, 4 million downloads, no idea what it is. Bad Boy 17G. And I think these were sort of the second or third page of these weren't like all the way down sort of on the list. Those extensions that you have here. So yeah, it's hard. It's hard to figure out. Now I'll have some examples here. So these are some malicious ones here. These are dark modes that you can have. Tracular dark. Okay. Not sure, but 42,000 or 45,000 installs on this one. And that one actually turned out to be malicious. This one. Here is, on the left-hand side, the good one. On the right-hand side, the malicious impersonator for a particular extension. You can tell the difference. So here it is prettier, make the code look prettier. That's kind of the goal here. Last commit, same number of pull requests, same number of open issues. The only thing that sort of gives away, this one was released in 2017, this one here more recently. But not that recent where you would say, okay, it's probably something malicious. And then, of course, the other thing, that was sort of with the NPM issue a couple of weeks ago, where a good extension, or in that case a library, goes bad. That happens too, where developers' credentials get compromised, and then someone is taking over a popular extension and making it malicious. So that's it. But yeah, there's no way that you could tell really here the difference between those two. So I mentioned already recent events. This was the latest, greatest one of these, class swarm. And the biggest extension being affected here was called Code Joy. Code in Klingon was another one that I kind of like. My wife is a little bit tricky, but she would probably tell you why you shouldn't code in Klingon. Did you know there's a big effort out to actually have Klingon finally added to the Unicode character set? So, I'm not sure if they're using it. Maybe in there. But one real interesting trick they have here is they use Unicode characters to actually have some of the malicious code in transparent font. So actually they had encoded strings in essentially white spaces, and then code that decoded those white spaces into code to execute. So when you look at the code for this extension, there's sort of just looks like a list of empty lines in the code. And this sort of a little bit reminds me of when cross-site scripting came out first. This was like back in the late 90s, so when I first went to cross-site scripting. And initially, I sort of thought, hey, what's the big deal? People are exploiting themselves because they're clicking on the link and then that code comes back to them. Sort of classic reflective cross-site scripting. I think with the Unicode stuff, we're a little bit at the same level right now, where everybody focuses on the URLs with like the lookalike characters and stuff like this, which actually most browsers doesn't really work well these days because they don't really display those characters. But in developer tools, in editors, did you know that many languages like JavaScript, Swift are Unicode compliant? You can write code in other languages, which again, if you don't speak English, that's a great thing. You can finally use the poop emoji as a variable name. But with that come things like left to right and right to left. You can code in right to left instead of left to right. If you set the right Unicode character to change the direction of the text. So there's a nice example where code looks benign when you're reading it left to right. But when you're reading it right to left, as the parser will interpret it, it will actually be malicious. You can think about when you sort of change a greater, less than, or something like that, where that sort of changes the comparison of like a password or something and opens up a back door. And this is, I think, another nice example here where Unicode is being used to basically obfuscate code here in new and interesting ways. Another thing I liked about this particular event is they used Google Calendar as a command control service, which I think is actually better than that blockchain thing. They also like added URLs to the blockchain, which is neat, but blockchains are really just for scamming people. Anyway, so the Google Calendar is one of those things, like in particular me, so being a little bit sort of a network nerd and IDS nerd, hard to detect that someone is using Google Calendar. And sort of build some indicators of compromise or such around that. Yeah, and then what was also interesting here is they were, like all of these tools, still developer credentials, that sort of basic table stakes kind of, but they were particularly focusing on credentials that developers use to publish their own extensions to these marketplaces. And then, of course, they can turn a good extension into something malicious. Maybe something that you wrote yourself to share in your company or something internal that they then add there. And that's sort of the warm part here of this particular malware, that it actually turned good extensions bad by stealing developers' credentials. Yeah, and then the other stuff is pretty normal fare for any kind of malware. Some kind of remote access Trojan here, hidden DNC and stuff like this. That's actually, I think, if I would write that software, and by the way, you can tell that I didn't write that software, I would remove that stuff because it just makes detection more likely, actually, if you have some hidden DNC in there. But anyway, a little bit AI here. We now not only have developers, we also have people called data scientists. They're like developers, but they know less about code and security. And in 2003, we noticed in our honeypots attacks, for example, against GeoServer. GeoServer is a tool to manage geographic data. The other thing we saw was, what's the tool here again? I draw a blank now. NFIX. It's a data management tool. It pulls in data from various sources and then outputs standard JSON or whatever you want to basically be used in your machine learning model or whatever. This tool is particularly interesting. It gets you this nice little web-based GUI, where you can sort of arrange different modules at basis of your data pipeline you can build there. It's a Java-based tool. By default, when you install it, who needs credentials? It's just open to the world. And you can just upload your own modules, which are code. So it has remote code execution built in. It's not a bug, it's a feature, as they say. And that stuff, attackers keep scanning for more and more. Like I said, in 2000, so 2 years ago, we sort of saw this increasing big times, these scans. Earlier this month, last month, CISA actually focused on a nice attack where this was actually exploited, where an attacker accessed your GeoServer in this case. Here they actually used the vulnerability. Like I said, often you don't even need a vulnerability. They're just exposed to the internet, those systems. And in particular, when you're looking at how these systems are often set up these days, you're not setting them up like in your little lab at home, because data scientists usually don't have labs at home. They do it all in the cloud. So they just spun up some virtual server in the cloud and then install the tool. It's now hidden by IP address, kind of. So that's the only thing between the attacker and remote code execution. Yeah, in this case, that CISA documented, they compromised GeoServer and then basically used it sort of for lateral movement, because that GeoServer now has access to all kinds of other systems in your data pipeline. And with that, you basically can just access whatever you want to. Okay. Oops, the monitor is acting up a little bit here. Hope it's visible in the remote. Let's see, okay. Yeah, other part of the pipeline here, DevOps, Jenkins. Whereas I sometimes have it seen referred to the WordPress of DevOps when it comes to vulnerabilities. These are complex tools. These are complex tools that, again, execute code, that touch code that you write, that touch credentials in order to build containers and move them live. And then people expose them. think the only thing actually keeps something like Jenkins particularly secure is not exposing it. But that's again hard if it's all in the cloud and all remote managed and such. So not exposing it can be hard. Similar Atlassian Confluence. Every month there is 1 or 2 vulnerabilities in these tools that are being used. And a second. I'm going to make sure that it's still visible here. Yeah. Okay. Yeah, and because exploits are so common in those tools, there are exploit frameworks written just for it. So whenever there is a new vulnerability, it now becomes a lot easier to exploit those vulnerabilities. These vulnerabilities are similar from each other, and then once you have that access to the tool, here like ghost jobs, it will basically you can add jobs to Jenkins that will not show up in the console. You can dump credentials. Also interesting, you can basically capture here with this Jenkins attack framework the output of the last job that ran, the console output, which often is like error messages and stuff like this, because it's code that doesn't really work well yet. And of course, for developing stuff like this, you're more verbose in what kind of error message you get. So there may even be a credential or something like this in there that wasn't removed. Yeah, and then basically just manage Jenkins for you. I would love someone would manage Jenkins for me. I have to expose it. Much easier than doing it myself. But anyway, yeah. Here, famous compromise of this kind of thing. JetBrains. JetBrains I mentioned before, big sort of developer tool manufacturer, and very popular. Actually, a really nice tool they have. One tool they have is TeamCity, which allows basically people to sort of work together on projects. Yes, it also had vulnerabilities. This particular vulnerability was exploited 2 days after the patch was released. So who is patching all developer tools within 2 days? And in particular, those complex tools like Jenkins and such, they're not easy to patch. It's not something that you auto-patch because you customize the tools. You write your own code that interacts with them, your own scripts and such. So, whenever you patch, you have to make sure that those scripts still work and that it didn't change a feature that you ran. So how do you protect all of this? I already mentioned don't expose it to the world. That's probably kind of your biggest thing that you can do here. Patching is fine, but like I said, it comes with a big caveat. You cannot patch as fast as they're being exploited. So you really have to buy yourself time, and you do that by isolating the tool. Like the isolation, I always say, it doesn't prevent the exploit in the end, but it buys you time. It makes it harder, makes it less likely. Because the first thing they're going to hit is everything they can just sort of scan for. Yeah, and then that's the other part is make sure the patches are applied correctly. I see this in particular with the Jenkins stuff, where you may sort of have hit the update button, but the patch actually didn't apply because some files were open and in use and couldn't get overwritten and such. So always make sure these are complex tools. Yeah, other defenses here. That's sort of, I'm not sure how many of you are sort of on the security side of this, like security teams and such. See a couple of, yeah, and then we have developers on the other side who is sort of more developer versus security. Anybody here sees themselves more as developer? In the back, of course, I see the developers, as I mentioned earlier. But there's often a little bit tension between security and developers. Because developers want to get work done. Obviously, developers are nice people. They sometimes have a hard time thinking evil and figuring out what could possibly go wrong. So it's really important to sort of set up that partnership where the security team assists developers in getting their tools secure. It doesn't just tell them, hey, you can't use that tool or that library. Because developers are sometimes also really creative in finding workarounds for that. And then they use the tool without the help. So develop some guidelines with developers, include them so those guidelines actually work and don't get in the way as they're trying to develop code. Yeah. Dependencies. It's like I said, sort of the big thing here. So developers, last night at dinner, talking about some of the early computing experiments. My first computer was actually a Commodore 64. Anybody here old enough? A couple of you here played with it. Have you typed in like hex code from some magazine? That's what he did back then. Yeah? I remember like there was this one assembler that I typed in. It was like sort of 30 pages of magazine. You type in 30 pages of hex code to make that work. We didn't have much dependencies back then. There wasn't really so much of an issue, but we probably didn't really know what we were typing in when we were typing in that hex code. These days, developers don't develop, don't code. They take libraries and then duct tape them together. That's how I code, so I'm not blaming anybody here. That's just how stuff works. And I mentioned earlier, like with Electron and such, and all the frameworks are the same. Just to get started, you should download like hundreds of dependencies. Some of those dependencies are like these minuscule pieces of code that you could probably have coded the time it took you to download and install it. Yeah, so now you have the dependency sitting here, the system, and anyway. So pip, as an example. Now, here in this talk, I want to specifically focus on attacks against developers. So this goes beyond including malicious code. What happens if you install a pip package? Well, you would think, hey, I'm just downloading stuff and then copy it in the right location. No. There are setup scripts that run, or that can run. And they can run any code as a developer. That's whoever is running it. So these setup code scripts basically run whatever code they want. And you need them. Some of these packages you may need to compile something or such. So you may need to adjust them to your system configuration, and that's what these kind of tools are for, what these scripts are meant to do. Now, there are two ways you can install a package in Python. There are these wheel packages. They're really more kind of what you think of, where it just copies stuff into the right directory. So they're kind of safer in that respect. And then you have tar packages, which basically just download the source code, then compile it. So you would say, hey, developer, just only use wheel packages. Don't use these .tar.gz. They're insecure. Only use the pre-compiled packages. And here's sort of just for those of you who think you can review the code, I have sort of a little setup script here, a malicious one. You probably know it's malicious because it's obfuscated like this. Yeah, this particular one extracts secrets from the browser, exfiltrates them, and then steals Discord data. A lot of the tools targeting developers are after Discord data, because that's what developers love to use these days, the kids, to communicate with other developers. So this is how an attacker then gets into the communication channels between developers and sees what they're working on. And have you ever, like, in Slack, Discord, or something like this, sent like a credential to another developer? Hey, to connect to the database, just use this password. So that's what they're after here. Gaming credentials, because developers love to game. And so they take them as well. And I think that's really just to get sort of their game accounts for other malicious stuff. And screen capture. So you told your developers, hey, developer, only use wheel packages. Well, here's an example. The cryptography package is a very commonly used package. Pretty much anything that uses like SSL or anything like this in Python needs that cryptography package. For ARM, it's not available as a wheel package. For x86, yep, you can do the wheel, but not for ARM last time I checked. Maybe they fixed that now because ARM is becoming more popular. But I was working on our honeypot stuff where we are running them on Raspberry Pis and such, so we need the ARM version of the package. And yep, not available. So we have to do the source distribution, we have to compile it. Entry points. You may have seen this in Python. When you install a Python package, it often installs these little command line utilities that you can use. To sort of get some of the functionality of the particular package sort of as a self-contained binary. Like if you install some image manipulation Python library, it may come with like a little tool that lets you run this. Well, these are called Python entry points. They're basically little scripts that are installed in a location that's in your path on your system. So now when you type, manipulate image, it calls this. What about an entry point called ls or something like that? So I can trick you into executing code this way, just by installing a package again, by installing these entry points on the system. Okay, so pip, one of the big ones, npm, another big ecosystem. Again, Discord is a big target here. So these particular packages here, they're actually meant to sort of help you write little bots and such for Discord, or stealing Discord tokens. And this is particularly tricky because now even if you would review the code, you say, oh, okay, this particular script needs access to Discord credentials. Well, I want to write a Discord bot with it, so that's actually kind of normal. But later it also exfiltrates those credentials to some other place. That's where it gets more tricky. So in NPM, we have these, again, sort of installed scripts, package.json, like before you compress it, pre-compress, post-compress, there's sort of different scripts that you can execute as the package is installed on the developer systems. So pretty much the same thing, and all of these ecosystems need something like this, because they all have the same problem that just copying the files in the right location doesn't always work. You need to run some code to adapt what you just downloaded. So yeah, you could review the script section, which again is okay. There's an ignore scripts option. So again, you're telling your developers always run the ignore scripts option, and well, and then a lot of the packages won't work. Yeah, here's another example. So here where it sort of runs this node index.js. That's the malicious script here. You're not going to necessarily, it doesn't stick out as anything malicious. Then you have to look at that script, and then maybe you see the obfuscated code. And even if you de-obfuscate, there's really a lot of benign stuff in there that doesn't necessarily immediately set alarm bells. Here, SH key, they're stealing secret SH keys. That may be the one line here that's a little bit odd, kind of. Yeah, NuGet, same thing when it comes to .NET. I mentioned NuGet earlier. Same basic problem. We have these installed scripts that can run arbitrary code on the developer systems as they're installing it. Anyway, I promised you a fourth one. So AI. Everybody wants AI. So yeah, I got some AI for you here. What happens when you download an AI model? Many AI mods you download are pickle code. Python. So Python pickle code is what you're downloading. You're downloading a Python script. You're not downloading just data as you're installing this, this machine learning model. So you're going to Hugging Face, the website where you download these, and just like all the other ecosystems, same problem. Anybody can upload stuff, including malicious scripts. And then as you're downloading, as you use the model, you're actually basically running eval. We're again, combining code and data. We have that model that looks like data, but then we call exec or eval or something like that on it, that'll actually execute it as code. Yeah, in Python, the PyTorch, that particular machine learning library, it has sort of that weights only equals true, which basically will only use the data, not the code. That actually didn't work right, and you still executed code. There's a guy who has a real good YouTube video about this. I forgot his name. Mark Baggett. Yeah, Mark Baggett. He has a YouTube video about some of that. Yeah? And so if you search for him about some of the risks here, actually basically you do serialization here, which is another sort of mixing or deserialization. It's another mixing code and data kind of problem. Yeah. And then of course we have AI coding assistants. Actually, just back to this here, and it's often not clear which code is written by it, not written by it. Again, it's something that you can't really tell your developers not to use or not to do. You want to put some guardrails around how it's being used. And then the good old, garbage in, garbage out problem. We had one of our SANS EDU students recently write a research paper. And one thing about these Copilot and these tools is they scan the code that you already have on the system, sort of as a baseline, to figure out like your coding style and various things that you're working on and such to better suggest code. The problem with this is if the code you already have is bad, they create more likely bad code. So this here what came out of this, probably used a little bit more data, but he basically, had Copilot create software, one on a system where he sort of pre-installed some bad, insecure code, and one where he had secure code. And you see how the insecure code base on developers' system did affect the quality of the code that was created. So yeah, it makes worse developers worse, or bad developers worse. So what about endpoint protection for developers? Anybody knows Wazoo? I like to play with that. It's a great tool. Yeah, I don't want to diss any tools here, but one problem I have with Wazoo on my developer workstation is I use a lot of Docker containers. And then you end up in Docker containers with all of these sort of files in /dev on your Unix systems. Which, yes, are a legitimate sort of indicator of something bad happening, not if you're running Docker containers. So you have to tune them. You have to tune these. This is something I ran into with my cat. So my cat has a little bit of a problem. She's a little bit overweight. So my wife came up with that, that's sort of a cat feeder that sort of doses like how much food she gets. And every hour or something like this, the cat feeder tried to talk to Baidu. And some IDS sort of went off on that. Turned out it was just a random Python library that it uses Baidu to check internet connectivity. It's probably written in China, and Google doesn't work there, so they used Baidu instead. And that stuff, again, on developer systems, when a developer used that library, all of a sudden you have this sort of beaconing. It was classic beaconing behavior. It was not malicious as far as I can tell, but certificates. How do you manage certificates for developers? I like to develop like TLS on my development websites too, and you need various, to connect the database, you need certificates. So developers often manage their own certificates, or you have some not that tightly managed certificate authority for it because it has to be flexible. So you get a lot of like self-signed certificate alerts and such on it. I do get CrowdStrike, which is a tool I use. It sometimes flags when I grep on my bash history. Any developer ever greps bash history, kind of? Because you get sick of doing the up key kind of thing. So that's another thing where you have to tweak your detection rules for developers because they work differently than your average office machine. This is a quick conclusion. Don't ignore your developers. Help them. Don't become their enemy. I mentioned sort of with extensions, but also with libraries. Make it easy to add new libraries to the allowed catalog. You rather want to know that they use it. Because if you don't let them use it, let me show you a little developer trick. Copy paste. So then you end up copy paste. So then you have the code, but you don't know that you have it. And so make it easy. Make that partnership work. Explain, show, demonstrate why it is a problem to do insecure things. And do your best you can to scan for it. You won't find all the problems. So the hybrid approach, endpoint, network, scanning, is probably going to help you the best. Anyway, do you have a couple minutes for questions? Okay, good. So any questions? Nobody? Okay. I do have stickers also. They're out at the SANS booth for the, oh, sorry? Oh, sorry, I didn't see that. Okay. Just shout and I'll repeat it. What's the second part? Yeah. Yeah, so how does the vulnerability work? Because the parser compiler for this language is Unicode aware, it will then tokenize the other way around. So this only works in languages that are actually Unicode aware. The question here was, how does it work with the right to left versus left to right, and how does the tokenization work? The tokenization is not left to right in that case, it's right to left. Does that answer the question? Yeah. Yeah, so the comment here was just, it's not what you're usually doing. Yeah? Use Emacs as your editor and you won't have that problem. Actually, Emacs is UTF-8, so Emacs may have that vulnerability. That's why you use VI. ED may be safe. I think VI does UTF-8 too. But okay, good. Yeah, so if anybody has any more questions, I'll stick around for a while. My information is here on the slide, and there are Internet Storm Center stickers at the SANS booth if anybody's interested. So thanks, everybody.